A cannon located at the top of a mountain, 100 meters high, sees an army approaching along a straight line. The angles of depression made by the soldiers are 5 degrees, 15 degrees, 25 degrees, 85 degrees, and their distances from the foot of the mountain are x1, x2, and up to x9 meters, respectively. Find the value of x1 into x2 into x3 into x4 up till x9. इनको multiply करना है, ठीक है? All right. So we start with the mountain and the cannon, okay? And we all know that the height is 100 meters. Okay, I draw the reference line and the line of action or the line of sight of or the line of the cannon is how much? The line of the cannon is 100 meters above the reference line. Okay. Now it is given that the soldiers are making some angle of depression, right? Let's take the first soldier. Okay, and the angle of depression is 5 degrees here in this case. Okay. Now, guys, you can observe that since these two lines are appearing to be parallel, okay, the blue line here, the line of contact of the cannon and the enemy soldier, that is a transversal, right? Across the transversal, the alternate angles are equal. Okay, so what I'm doing is I'm taking a triangle where tan 5 is nothing but the height here 100 divided by the distance of the person from the cannon here, right? Okay, so here it is given that foot of the mountain se leke soldier tak the distance is x1. So apply tan phi, as I said, tan phi will be 100 upon x1. If you write in terms of x1, x1 is 100 upon tan phi. Okay, guys, the same thing you can observe for the second soldier also. The angle of depression is 15 degrees by alternate angles. Okay, the angle is 15 degrees. So its distance is x2 from the base of the mountain. So again, we can write tan 15 as 100 divided by x2. x2 equals to 100 by tan 15. Okay, likewise you can write it for all the soldiers here. Okay, the last soldier will make an angle of depression of 85 degrees. So tan 85 is 100 by x9. Okay, now all these equations, guys, you simply multiply them. When you multiply, the left hand side becomes x1 into x2 into x3 up to x9. Okay, and the right hand side becomes 100 by tan phi, 100 by tan 15, 100 by tan 25, 100 by tan 65, 100 by tan 75, 100 by tan 85, all these values. Okay, now here, guys, 85 is nothing but 90 minus 5. 75 is nothing but 90 minus 15. 65 is nothing but 90 minus 25. So all these values can be written as their complements, 90 minus that, right? Okay, so that's exactly what I'll do in the next step. Okay, the latter values after 45, basically. Okay, I'll write all these values as tan of 90 minus 5, tan of 90 minus 15, tan of 90 minus 25. इसके पहले क्या आएगा? Tan of 90 minus 15. उसके पहले क्या आएगा? Tan of 90 minus 5. उसको ऐसे ही छोड़ दो 45, right? Now, tan of 90 minus theta, guy, we know is cot theta, right? So this will be cot 25. This will be cot 15. This will be cot 5, so on and so forth, right? So this will continue up till the next one, cot 35. उसके पहले एक term आएगा cot 35 का. Okay, then again tan 45, tan 35, tan 25 will be as such. Okay. Now writing the next step, guys. Okay, all these values will be written in terms of their cot ratios, right? Okay. So if you observe carefully, guys, ये है tan phi starting में और ये है cot phi starting में. We know that tan theta is nothing but 1 upon cot theta. Or if you multiply these two, tan theta into cot theta will be 1. Okay, so product of tan phi and cot phi will basically give you 1. They get cancelled out. Similarly, tan 15 and cot 15 get cancelled out to give you 1. Tan 25 and cot 25 will get cancelled out. Tan 35 and cot 35 will get cancelled out to give you 1. And बीच में एक ही टर्म बचेगा tan 45 जो कि 1 के बराबर है. So the right hand side is nothing but 100, 100, 100, 100 multiplied 9 times. And that's why the answer is 100 raised to the power n. Okay. That should be it. But I think we should solve one more question. Actually, it's a very good question. Let's go for it. Consider a regular hexagon A, B, C, D, E, F. There are two towers placed at B and D. The angle of elevations from A to the top of the towers B and D are 30 degrees and 45 degrees respectively. What is the ratio of the heights of the towers at D and B? Okay, now guys, so before solving the actual question, let's have a regular hexagon before our eyes. Okay, a regular hexagon will have all of its angles as 60 degrees. No, 120, right? Yeah. So all the angles will be 120 degrees, right? N minus 2 into 180 divided by N. So 6 minus 2 into 180 divided by 6. 4 into 180, 720 upon 6 is 120 degrees, okay? All right. Now, guys, if all the angles are 120, if I drop one perpendicular from B to the diagonal AD, in this case, ये angle 90 होगा, ये भी 90, ये भी 90, ये भी 90. Since, guys, all the angles are 120 और इतना part 90 है, बचा हुआ part कितना होगा? 30 degrees. ये भी कितना होगा? 30 degrees, right? Okay. So now I assume the side of this regular hexagon has 2 units. Okay. And I told you this angle is 90. This angle is also 90. Okay. Applying, sine 30 in this case, sine 30 is half. Okay. So this length here, Okay, this length will be 1 unit because sine of 30 should be half. तो अगर ये 2 है, ये होना चाहिए 1. Okay. अगर side of the hexagon guys अगर मैंने 2 माना हुआ है, okay, this entire thing consists of right angles here. So this will be a rectangle, right? तो अगर ये 2 है, ये भी कितना हो जाएगा? This part also will be 2. Okay. And since we found this length as 1, okay, ये length भी कितनी हो जाएगी? 1 units, right? Okay. So if you look at AD guys, AD in total becomes 1 plus 2 plus 1 equals to 4. Okay. So the longest diagonal, you can take it as standard also. If you take the side of the regular hexagon as x, the longest diagonal will be equal to 2x. Okay, that's the proof basically. All right. Now let's look at the actual question asked. Okay, we have a regular hexagon. Okay, it should be in 3D actually. And there are two towers at points B and D. Okay. And we're supposed to find the ratio of the heights of the towers at D and B in this case. Given the side of the regular hexagon is 2, we've assumed, and length of BD is 4. Length of AD is 4. Okay. So let's take the first tower at point D. Okay. At point D, okay, this tower at the point D here, this tower here at point D. Okay. Iska distance from point A is how much? 4 units, right? That which we have actually assumed. So उससे हमें 4 आया था, AB का value में 2 assume किया था, we got AD as 4. So if AD is 4 guys, we can apply the 30, we can apply 45 45 90 theorem, or you can apply tan 45 here, whichever way you like. Tan 45 will be equal to PD, okay, this length here PD divided by AD here in this case, right? AD is nothing but 4 and tan 45 is 1. यहाँ से हमें PD की value मिल गई equals to 4. So height of the tower at point D is equal to 4 units. Okay. Now let's talk about the point B here. At point B we have this tower. उसको मैंने यहाँ draw किया है नीचे, enlarge किया है side में. Okay. This length is nothing but AB, right? AB which we assumed as 2. Okay. देखो ये वही है ना, side of the hexagon 2, right? Okay. Now in this you can apply again tan 30. Tan 30 we know is nothing but 1 by root 3 in this case. Okay. So taking this point as Q, we apply the tan 30 in triangle ABQ and we get tan 30 equals to QB divided by AB. Okay, AB is 2 and tan 30 is 1 by root 3. So यहाँ से हमें मिल गया QB का value 2 by root 3. QB is the height of the tower at point B. So now we want the ratio of the heights of the towers at points D and B respectively. At the point D, the tower is PD, उसका height हम 4 निकाल चुके हैं. And at the point B, the tower is QB, उसका वापस हम height निकाल चुके हैं 2 by root 3. Okay, so the ratio required is 4 is to 2 by root 3. 2 to cancel. 2 into root 3 is to 1. The ratio is 2 root 3 is to 1. Okay, so I hope you've got sufficient idea regarding the heights and distances, guys. We'll meet in the next class where we go on to circles. So see you next time.